Hello, in this video I'm going to explain divisibility rules. Now we don't cover divisibility rules in Math 25. However, they are covered in Math 50 and for Module 2 in Math 25, that optional module, knowing the divisibility rules are really helpful and you'll see why later on. So right now what you're looking at is a screen of Math 50 right here. So this is an example problem in Math 50. Module 2 of Math 50, this is the first thing you'll see. So it's good to kind of get a preview of this and also to understand divisibility rules. All right, so what are divisibility rules? Basically, what that means is that you're asking the question, can one number divide into another number evenly with no remainder? So let's say, for example, let's take the number 4 divided into 12. Does 4 divide into 12 evenly with no remainder? It does. And the answer is 3. Because 4 times 3, right here, 4 times 3 is 12. So there's 0 remainder. So what we say is that 12 is divisible by 4 because there's no remainder. All right, so that could be important in certain parts of math. So divisibility is just the techniques you will learn is basically a quick way to determine if one number is divisible evenly with no remainder from another number without doing this division steps, these long division steps. You want to avoid this if you can. If you have to, you'll use it, but the divisibility rules are techniques to help you avoid this. All right. So now there are many divisibility rules. We're not going to cover them all. As you can see here, there's only 5 that are covered in Math 50. There are definitely more, but we'll just cover the ones that they show us here. All right, now, question number 1. Determine whether the number, the 78, is divisible by 3. And then you got to give a reason based on the tests for divisibility. So again, we don't want to use long division. They don't want us to do this. We could do that, but we're not. We're not supposed to. We got to use the rules of divisibility. Now, so what are they? The only way you're going to find out is to actually look at the help. Otherwise, you would know how to answer these questions. At first glance, no doubt, these are overwhelming questions, but I'll explain to you. I'll show you a good way to tackle these. All right, first thing you want to do is go into question help, view an example, click continue a few times, okay, to get everything in here. Now let's read the example. Let's do the example. Look at it. Determine whether the number, now this is the example, a different problem, whether the number 39 is divisible by 3. All right, so how do we determine that? And here we go. Here's our answer. A number is divisible by 3 if the sum of its digits is divisible by 3. So what they're saying is, we're going to take this 39, and then it says the sum of its digits. That's one digit, that's one digit. So if we sum up the digits, we get 12. And then we ask ourselves, is it possible for 3 to divide into 12 evenly with no remainder? And the answer is yes, yes. So if 3 divides into the sum of the digits, which is gotten by adding the digits, then guess what? 3 automatically, guaranteed, also divides evenly into the original number. Okay? So that's how we're going to tackle this thing. So first thing we got to do is to determine whether 3 or this number is divisible by 3. First, we got to determine, is it yes or is it no? And then, look at all these choices. We got to determine which one, which yes and which no. And to determine that, we have to know the rules of divisibility. All right, so here we go. Here's the problem. Okay, so we got 78. Now the rules say to add the digits, right? Add the digits. Well, 7 plus 8 is 15. Does 3 divide evenly into 15 with no remainder? Absolutely it does. 5. 3 divides into 15 5 times because 5 times 3 is 15. We have 0 remainder. So yes, 15 is divisible by 3. So we know the answer is yes. But which yes? There are several yeses here. So the best way to do these guys is first determine if it's yes or no, and then which yes and which no. So let's begin by going down the list. We know it's a yes, we can skip A. Could it be B? Let's look and let's read it and see what it says. Yes, it is divisible by 3. The sum of its digits is 15, which is divisible by 3. Now that looks like a winner. But let's see why the other yeses are not going to work. Yes, it is divisible by 3. It's one's digit. Oh, it's one's digit, it says, which is this thing, right? This is the ones digit right here. Its ones digit is 8 and is even. Did the rules say anything about the ones digit? No, not for the number 3. For other numbers, it might matter, but not for the number 3. So this is, a distraction. This is to see if you know the rules. They threw that in there. That makes no sense because the help did not say so, okay? We're not going to look at the ones. Let's look at the next yes. It says it's divisible by 3. It's one's digit. I'm going to stop reading right there. I'm not reading anymore because I know we don't care about the ones digit for the number 3. So it looks like it's going to be B. Out of a process of elimination, we cut this in half by knowing whether it's yes or no. And then we went down the line and eliminated the yeses that made no sense. And we got that information from the help. All right, now we're on question 2. Now this is a different number. This is the number 5. Are we going to add up the digits for the number 5? I don't know. Let's find out. All right, don't guess. Go in here and look and see what it says. Determine whether this number is divisible by 5. Give a reason based on the test for divisibility. So here's the rule right here. A number is divisible by 5 if its ones digit is 0 or 5. Oh, so we're not going to add the digits for the number 5. Okay, it's a different rule because it's a different number. That makes sense. Also, it might make intuitive sense for you that regardless of how big the number is, if this digit, if the ones digit is a 0 or a 5, then we know 5 goes into it. If this ones digit is something else other than 0 and 5, 5 does not divide into it. Now, if you recall, all right, if we just keep adding 5s, what do we get? Let's see if we can determine a pattern. So let's go down this way. 5, 10, 15, 20, 25, 30, 35, and so on. Notice that the ones digit just flip-flops between 0 and 5 right here. See that? So it doesn't matter how big the number gets. I don't care how big the number gets. It's the ones digit that we're looking at. If it ends in 0 or 5, 5 guaranteed divides into it evenly with no remainder. So it would be divisible by 5. Now let's go back to our original problem and see if we can figure it out. Okay, there we are. 6748. Now remember, this is the key, right? The ones digit. If it's 0 or 5, this number, whole number here, is divisible by 5. Well, guess what? It's not 0 or 5, it's 8. It is not divisible. It's not divisible. So the answer is no. Now we got to determine which no. Here we go. So let's look at A. No, it is not divisible by 5. Its ones digit is 8, is even, but the sum of its digit, this makes no sense at all. No sense at all. It's not A. Let's try B. It is not divisible by 5. Its ones digit is not 0, 5. This makes a lot of sense. It looks like it's B. Let's keep going, though, and see why the other no's don't work. No, it is not divisible by 5. The sum of its digits, we're not adding. Nope, we're not doing that. And then down here, it is not divisible by 5. The sum of its digits, we're not adding. So hopefully you see the pattern here, right? First determine if it's yes or no, and then which yes and which no. So they're not as bad as they seem originally. What's important is for you to understand the divisibility rules. All right, so we have the number 10 here. What does the rule say for the number 10? And I bet you probably have an idea. All right. A number is divisible by 10 if its ones digit is 0. That makes sense. Let's look at a series of numbers. 10, 20, 30, 90, 170, 2,340. All of these end in 0. See that? They're multiples of 10. So 10 divides evenly into all of these numbers with no remainder. All right, so if the number ends in 0, then the number is divisible by 10. Simple as that. So the ones digit, the ones, right? The ones column plays a role. The ones digit has to be 0. So you know, you just gotta look at each rule separately, okay? So let's go back to our original problem. All right, we have this huge number, right? Big number. Is this divisible by 10? Is the ones digit a 0? No, you said. Correct. All right, so the answer is no. So let's figure out which no. Let's try A. It is not divisible by 10. Its ones digit, 0, is even, but the sum of its digits, nah, nope, nope, nope. Let's try B. It is not divisible by 10. Its ones digit is not 0. That looks good. Let's keep going, though, just for fun. E, no, it is not divisible by 10. The sum of its digits, we're not adding. We're not adding. Nah. Nope. All right. So our next problem, or our next number, is the number 9. All right, so let's see what the rule for 9 says. A number is divisible by 9 if the sum of its digits is divisible by 9. That sounds familiar. It's the same rule as 3. So the number 9 and the number 3 have the same rule. And that is because 9 is a multiple of 3, but that's a side note. So for the number 9, we have to add the digits and then see if 9 divides into the sum of the digits like we did for the number 3. All right, so we got what we needed out of help. Let's get out of help and try the original problem. 34, 54. We're going to add these guys. We're going to add them up. 3 plus 4 is 7. 7 plus 9 is 16. Now the question is, does 9 divide into the sum of the digits, which is 16, evenly with no remainder? Let's find out. So 9 divides into 16 one time. 1 times 9 is 9. No, it does not divide evenly. We have a remainder. All right, so it is not divisible. The answer is no. This number, 3,454, is not divisible by 9. It's pretty neat when you think about it, right? In one, just by adding the digits here, in several seconds, you determine whether this big number is divisible by 9. It's a good party trick to impress your friends. All right, so let's go back to our problem here. We know it's no. Let's see which no. Let's see if could it be that one. It is not divisible by 9. It's 1's digits. Did help say anything about the 1's digits? No. Skip that one. It ain't that one. Let's try the next no. It is not divisible by 9. The sum of its digits is 16. Is divisible by 9. This really makes no sense. No, it's not that one. Let's try E. It is not divisible by 9. Its 1's digit is, do we care about the 1's digit for the number 9? No. Let's look at the last no. No, it is not divisible by 9. The sum of its digits is 16, which is not divisible by 9. All right, last one here. And I bet you might know or be familiar with this one too. So now we're looking at the number 2. Okay, so the next problem here, problem 5, we're looking at the number 2. So I have a feeling that for this problem, you might be familiar with the concept of divisibility with 2. All right, so let's see what question help says. A number is divisible by 2 if it has an evens 1's digit. Okay. All right, now let's review the word even and odd. Even, odd. So a number is even if it ends, if the 1's digit is 0, 2, 4, 6, 8, and we covered that in Math 25, right? Module 0. It's odd if its ones digit is 1, 3, 5, 7, and 9. So what they're saying here, regardless of how big the number is, so here in the example, the number is 14,805. I don't care how big the number is. I'm zeroing in on the ones digit. So, is it even or odd? Well, it's 5, which means it's odd. If the number is an odd number, it is not divisible by 2. If this digit here would have been any of these here, it would have made it an even number, and it would have been divisible by 2. Okay, so if a number ends in 0, 2, 4, 6, 8, it is divisible by 2 because it is an even number. That's what they're saying here. All right, so let's go to our original problem. Again, we have a nice big number, but we don't care, right? We can handle that because all we're looking at is the ones digit. It's odd, which means it is not divisible by 2. So we know the answer is no, and let's go find the exact answer. Let's try C. Let's read C and see if that could be it. It is not divisible by 2. Its ones digit is 1, right? It ends in 1. There it is, which is not even. That looks like a winner. Let's look at the rest, though, just for fun. No, it is not divisible by 2. Its ones digit is 1, is even, makes no sense. Let's look at F. It is not divisible by 2. The sum of its digits, we didn't add anything. Nope. And down here, we did not add anything either. All right, so something tells me it's got to be C. All right, and there it is. So, so that's how you look at and examine divisibility rules. These are important rules for your sections coming up. So if you like my video, if you like the content, click on the like button, post your comments, and subscribe to my channel. Thank you for watching.